Hello to all the Form 5 students. Today we will continue with the inverse variation. Alright, you have just learned direct variation and joint variation. So today we will learn inverse variation. What is the meaning of the inverse variation? So while on a seesaw, the heavier person will be at a lower position, whereas the lighter person will be at higher position, right? So do you know how to balance a seesaw? To balance a seesaw, the heavier one has to sit closer to the fulcrum of the seesaw, or the lighter one has to sit further away from the fulcrum. Observe the diagram on the right. The relation between the person's mass and the distance between the person and the fulcrum is say very inversely. When the mass increases, the d decreases and vice versa. So explain the meaning of the inverse direction by observing the seesaw. Alright, so let's go through this one. If you carry out the result for this one, the activity for my mobilization to explain the meaning of inverse variation, understand the following situation and then answer the question in the discussion. A school hall has a few doors. The table below shows a relation between the number of doors open and the time taken, why, for a group of pupils to leave the hall. So number of doors open increases. Does the time taken for the pupil to leave the hall increase or decrease? Alright, so as you can see, when the number of doors increase from 2, 3, 4, 5, 6, the time taken actually decreased from 24, 16, 12, 9.6 and 8, right? Alright, so you can see from here, this one is decrease, and this one is the number of doors is increased. So if the number of doors open decreases, does the time taken for the pupil to leave the hall increase or decrease? What is the relation between the number of doors open and the number of time taken for the pupils to leave the hall? The result of my mobilization 5 show that when the number of doors open increases, the time taken for the pupils to leave the hall decreases. Similarly, when the number of doors open decreases and the time taken for the pupil to leave the hall increases. The change in the number of doors open leads to an opposite implication to the time taken for the pupils to leave the hall. Alright, so this relation is known as inverse variation. In general, let's have a look of the definition for inverse variation. Variable y increases when the variable x decreases at the same rate, and vice versa. This relation can be written as y varies inversely as x. So in Mandarin, the inverse variation is called fan bian. And then it's always like the one of the variable increase and the other one will be decrease. Okay, so this is called inverse variation. Okay, so let's see this example. Chiang takes part in a 42-kilometer marathon. The table below shows a relation between the time taken by Chiang and his average speed. State the change in average speed if time taken increased by 2 times. What is the change in average speed if time increased by 2 times and if the time decreased by 1.5 times? So as you can see, the time, okay, when you observe 4, 5, 6, 7, 8 is increased, right? And as you can see, the average speed is decreased, right? So this is actually the inverse variation. So if let's say the time 2 times, from 4 the times become 8, it become 2 times, and hence the average speed will be divided by 2. Okay, it will be divided by 2. Just now is times 2. Alright, so when the time increase 2 times, the average speed decrease 2 times, right? Okay, when the time decrease 1.5 times, the average speed increase 1.5 times. Okay, so this is how we do the inverse variation. It's always if increase is always multiply, if decrease is always divide, right? Okay, so let's have a look of the self-practice 1.2a. Self-practice 1.2a. The table on the right shows the relation between the number of workers and the number of days needed to install tiles in a house. State the change in number of days if the number of workers is multiplied by 2. Alright, number of workers multiplied by 2. Okay, we need to state the change in number of days. Okay, if you multiply by 2, from 2 worker become the 4 worker, and then you notice that the number of days is actually divided by 2, right? So we can say the number of days is half, right? So the number of days, so how to answer this question is number of days is half. Alright, is half divided by 2. So we actually write is half. Okay. So the change of number of days, if the number of worker multiplied by 2 is the number of days is half. Alright. So let's see the next one. What about if the number of worker, okay, decrease by half? Okay, if decrease by half, that means from 4 it become 2, right? So the number of days will be double, right? Okay, for this one we will say the number of days, the number of days is double, right? Do you understand? As I shown in the green arrow, 4 become 2. So it means that the 4 divided by 2. So when the number of workers change from 6 to from 4 to 2, the number of days will be changed from 6 to 12. It will be double. Alright, the change in number of days from 6 days to 12 days. When the workers change from 4 to 2, alright, 4 workers become 2 workers. So numbers of days change from 6 become 12. So it becomes double. The number of days is doubles. Alright, clear? Okay, so clear. So now we discuss question number 2, which is, okay, let's clear some space. Cikgu Farid, okay, has a sum of money to buy gift for the winners for a mathematics quiz. The price of a gift is 10 ringgit. Then Cikgu Farid can buy 10 gifts. State the number of gifts that can be bought if the price of the gift increases by 2 times. So if the price of the gifts increases by 2 times, then the number of gifts will be half, isn't it? The number of gifts decreases half. Alright? Okay, that is A. For B, state the number of gifts that can be bought if the price of a gift decreased by 50%. So if the price, okay, we are asking to state the number of gifts if the price decreased by 50%, then the number of gifts will be increased. It will be reversed, right? One or increase, the other one will be decrease. So the number of gifts will actually increase, right? Increases 50%. Okay, increases by 50%. Alright, so we have discussed the example of the inverse variation. We also discussed the exercise 1.2a. Now, what is the relation between the two variables for an inverse variation? So now we want to figure out the relation between the two variables of an inverse variation. Okay, so now let's discuss this one. If we do this example, okay, we try to compare the area. This is a very good example. So if we try to draw the graph y against x and graph y against 1 over x using a suitable scale, compare the values of x and y, then we will actually find out that the value of x, y is a constant and k is equal to the xy. The graph of y against x is a hyperbolic and the graph of y against 1 over x is a straight line that starts from the origin. So that means when y varies inversely as x, so you will have the graph like this. So if you plot the graph y against 1 over x, this is 1 over x, you will get a straight line with a gradient equal to a constant. Okay, basically you will get the graph like this. Okay, so if, okay, let's say we do this exercise to determine the relation between two variables of an inverse variation. So a piece of cardboard has an area 1.44 meters square. The cardboard will be cut into y small square cuts with an area of x meter square. So you have to actually open the worksheet and then try to calculate the area of the cardboard, which is 1.44, and area of the small square cut and number of the square cut. So if you multiply, you get 1.44. Then you have to find the xy. You have to find 1 over x, because as you know, you have to draw the graph y against x and then graph y against 1 over x using the suitable skill. So after draw the graph, you will get the graph like the shape of the graph will be like this. Okay, so I have explained about the graph. So now we can conclude that this is a very important conclusion. When variable y varies inversely as x, the value of xy is a constant, which is represented by k. That means xy is a constant, is a k. Alright, so as you see this one, relation between the value of k and the concept of the proportion. So you have x1 times y1, x2 times y2, x3 times y3, and x4 times y4. You get a constant k. Now relation between the value of k and the gradient of the straight line start from the origin of the graph. If you plot y against 1 over x, you will notice that the gradient is actually a constant, which is equal to x1 y1. Okay, so the relation is true only if the straight line start from the origin. Alright, so we can conclude that this is the most important conclusion. So when two variable varies inversely, when you multiply the two variable, you will get a constant. Okay, or you can say y equal to constant over x. So for an inverse variation, this is very important. Y varies inversely as x can be written as y varies inversely as x. Okay, and then y equal to k over x. Right, the graph of y against x is hyperbolic. Okay, hyperbola. And the graph of y against 1 over x is a straight line. And the line is start from the origin. Okay, so please remember, this is the graph of y against x, and this is the graph again y over 1x. Alright, so y equal to a over x, where x cannot be equal to 0, is a reciprocal function with a hyperbola graph. So this is called reciprocal function, and the shape is hyperbola. Okay, so you have to memorize the shape and the name for the function. Alright, so let's go through the inverse variation. Y varies inversely as x and can be written as this, and then when equation form, you should have a k. So the graph y against 1 over xn is a straight line that starts from origin. The k is the gradient of the straight line. Okay, so y varies inversely with x is true if and only if n equal to 1. So let's discuss example 16. So it's given that the time needed to assemble a piece of furniture varies inversely as the number of worker x. The table below shows the relation between x and the time. By calculating the value of xt, So we multiply 2 times 180, 360. Determine whether the t varies inversely as x or x squared. So if we multiply, we will get a constant. That means the x varies inversely as x, right? The time varies inversely as x. So we can say the xt equal to k, right? Or you can say that x equal to k over t, the same. So write the relation using the symbol proportional to. Proportional to means that we have to use a symbol for the inverse variation using the symbol. So the value of the t, let's have a look. If we do calculation, 2 times 180 we get 360. 3 times 120, 360, 490, 360, 5 times 72, 360, 6 times 60, 360, right? The problem is if you take x squared times with the t, you get 720, you get 1080, 1440, 1800, 2160. We actually cannot observe the constant for this one. For this one, yes. The constant, which is 360, which is remain unchanged. So we can say that a x vary inversely with the time, or you can say time vary inversely with the x. Alright? Okay, so let's see this example. Two quantity x and y vary based on the table. On the right, by using a suitable graph, draw the graph y against 1 over x. Show that y varies inversely as x. So now we study the table and we will draw the graph. The graph looks like this. Okay, so the graph of y against 1 over x show a straight line that starts from origin. Hence, y varies inversely as the x. Okay, so you must make sure the graph passes through the origin. Okay, that was using graph. For number 18, it is given that x equal to 0.25, y equal to 3. Express y in terms of x. If y varies inversely as x, so y varies inversely as x, and then we will make it equal. Write the relation in the form of equation, and we will substitute the value given. We are given 0.25 and 3, so we will find the constant. Substitute the value of x and y into the equation to obtain the value of constant, and the constant is 0.75. Hence we rewrite again, substitute the k in there, write again. So this is the equation, right? Okay, for b, y varies inversely as the square root of x. So by writing into equation, we have equal sign, and by substituting the value given, we can solve the k. After we solve the k, we can say y is 1.5 over square root x. Alright, so the method almost the same like our previous exercise. So y varies inversely as x. This is how you write. Varies inversely with x. When y varies inversely as the square of x. So when you see the square and inverse, it must be at the denominator. And for number 3, y varies inversely of cube of x. So this is how you try to learn varies inversely with the x squared or cube. Alright, so now today we will discuss a few example. Example 19, And then we have example 20, and after example 20 we'll actually do the exercise 1.2b. So I will give you a few exercise you try to do on your own. All right, okay, so the example here. So while you read the example F, let's see, we highlight. Okay, let's highlight together. F varies inversely as square of the distance. Okay, so this is our answer. Okay, D is the distance between the two objects. Given that the force of gravity between two objects is 15 and the distance between them is 1.2, write an expression of F in terms of D. So what you need to do is you substitute all the information and then you solve the K. After you got a K, you write back the equation F equal to 21.6 over D squared. Alright, so that's 19. So it is given that P varies inversely as Q. So if P is 2, we write the relation, then we change to equation. Then we substitute P is 2 and then Q is 7. So we found the K first, which is 14. So we will substitute K equal to 14 into here. Then we will have the new equation so that we can find the P and Q respectively. So now because the Q was given 1.6, so we can substitute the P is equal to 14 over 1.6 and P is 8.75. Alright, so the way to do is almost the same with the previous exercise. So now you try to do the exercise 1.2b. Right, so let's have a look of these two tables. Determine whether y varies inversely as x. If yes, write the relation to form the variation. Okay, now you try to multiply the x and y. Are you getting the constant? Maybe we can get this one. This is 6, 6, 6. This is 5 and this is 3. So sorry, y does not vary inversely as x, right? Okay, because there is no constant for the xy for 5 and 3, which is not 6. Okay, let's see how about b. For b, we actually need to try to multiply the xy. Y varies inversely as x squared. So now you try this. You try to find the x squared because the question asking for x squared. 1, 4, 9, 16, 25, right? Now you try to multiply the y and the x squared. Can you get a constant? So we try to write the answer here. X squared times y. So this is 3.6. This 3.6. This 3.6. This is 3.6. This one also 3.6, right? So that means for this one, y is varies inversely as the 1 over x squared. Okay, so we can actually write the relationship between x and y. Okay, so this is about the exercise 1.2b. So for question number 2, you are asking to plot the graph for this one. So you use a piece of graph paper, you try to draw. So this is 1 over r and this is current. So I think if you draw properly, you get a graph something like this. It's a straight line. So the graph I against 1 show a straight line. It must be a straight line. Okay, if you have a straight line, and the straight line that start from origin, that starts from the origin. So that means we can say that I is actually varies inversely as R, okay, based on the graph. Now let's discuss G. G, let's see how to do G. Okay, for G, given that G is 0.15 and H is 8, express G in terms of H. So first of all, G varies inversely as 1 over H. So that means we can say that G is equal to K over H, right? So we need to substitute 0.15 is equal to K over 8. So we can find the K, right? K is 1.2, right? So then we can say, we can substitute into here. So we can say that G is let's write down G is 1.2 is the constant over the H. Okay, so for A, the answer is G is equal to 1.2 over H. Okay, G is equal to 1.2 over H. Alright, so for this one, we have to start with the G varies inversely with the 1 over H square. So that means GH square is actually a constant. Or you can write G is equal to K over H square. Right? So we need to substitute the value. So the K is 8 times 0.15 square. Okay, so you can use a calculator and press G H square equal to K, and K is 8 times 0.15 square. So the K is equal to 9.6, right? So we can say that G is equal to 9.6 over H square, right? This is B. And then for C, G varies inversely as the cube root of the H. So cube root means that 1 over H 1 over 3, right? Okay, so if you write into equation, G is equal to K over cube root H. So we substitute the value inside is 0.15, G is 0.15 equal to K, and then cube root of 8 is 2, right? So that means K is 0.15 times 2 is K. So K is 0.3. So you can write again the equation. We can just erase the K and we just substitute 0.3. So this is the answer, right? 0.3 over cube root of H. Alright, okay, so for the rest of the question, I think you should know how to do, right? So like question like this, you just make it equal y you can write yx equal to k. Find the k first. Okay, this one you can put y square root x equal to k. Find your k, and after that use back the k. After you got the k, okay, let's see, I do this one. So the k is actually k is equal to 0.5 times 16, which is 8, right? So after I got my k, I can say that y is 8 over x. And then I can find the value of y when x is 0.04. So I'm going to substitute x, which is equivalent to 0.04. 8 over 0.04. So the answer is 200, right? So that's how you solve it for number 4A. Okay, for the rest of the question, you may try on your own. You can try for B, you can try for C and D. Alright. Okay, so I just tell you the answer. For the B is 32 millions. Okay, we have 60. Oh, wow, so big. For C you have 10, and then for D you have the answer is 3.684. okay, so you can try first. Alright, so question involving table, the concept is the same. You try to make the constant the same. 3 times 2 is 6. That means if you want to get 6 here, so this one should be 4, right? And this one should be 6 over 5, or you can say 1.2. Alright. Okay, so for the next one, okay, let's see this one how to do. To be continued from question number 5, 6, 7, I will discuss in my next video. So that's all my sharing for today. Till then, I shall see you in my next video teaching. Bye bye and have a nice day.